Hello. Today we're going to be talking about our project UAV swarm simulation using a biomimetic algorithm for rescue situations. My name is Shay.
My name is Eddie.
So the problem we wanted to tackle here was um, the case where you would have multiple stranded hikers in the event of some sort of natural disaster, and there were a large enough number of hikers, and the distance between them was sufficient that some consideration would have to be made as to the exact path a rescue team would have to take in order to collect all the survivors, um, considering the cost and time spent for that particular operation. So we looked at this and figured out that a good algorithm to use here would be ant colony optimization as a way for picking out the path that covers the least distance yet hits all of the points or the hikers. Once this path is found, then the hypothetical rescue team could send out a helicopter or a ground-based team to rescue all these individuals through this best path.
Okay, so in terms of the problem statements, we are trying to solve. So assuming that the hikers reports their coordinates through their GPS, and we will be able to obtain all the locations of each hikers, and we will put those locations in a 3D space in order to calculate the distance matrix. And at the time we obtain the distance matrix, we will pass that distance matrix into the ant colony algorithm. And as we run the algorithm, in each iteration, a drone will be sent out. And as the drone found the best path that it travels, it will amplify that path and store it to the ground base. So as the iteration continues, we'll be able to see a best route that allows the drone to travel in the shortest time, which also means that the rescue team could follow that route to get to every spot to to get those hikers. So the methodology here would be first we will set up a 3D space in Python. And here we use a function that is based on x and y value with the trig functions so that we can generate like imaginary hills and calculate the distance to travel in that 3D space. And the maximum elevation is set to 1,600 feet, and this is based on like the tallest mountain near in San Luis Obispo area. So we will calculate the trajectory distance from each spot to another, and like I said, that um, those distance will be able to form a distance matrix, a 2D distance matrix. Then we'll pass that matrix to the ant colony algorithm, and again, it will solve for the best traveling route.
So here's the results of all of our work. We have simulated 6 individual hikers or survivors placed randomly along the terrain, and using the ant colony optimization, we first started with all possible paths, which you can see on the left. And I think in 30 seconds, the algorithm narrowed down to the best path, which is shown on the right there, with a total distance of 25.19 miles. And that's actually the ground distance. So that's calculated by taking individual segments along the terrain. It's not the straight distance between the points. So yeah, next slide. In addition, we added a little bit of a visual flair. So here's another simulation being run using some functions in Matplotlib. We were able to dynamically update the plot to show the paths disappearing as the pheromone built up on the shortest path. So that this adds a little bit extra. You can see that the distance is a bit longer here because, like I said, this is a different case. Next slide, please. Yeah, so overall, We found that colony optimization was a suitable method for mapping out time critical routes for rescue missions involving multiple locations. It's worth mentioning that we only really see this method as useful for large numbers of stranded individuals over large distances. In the case where it's like two or three, yeah, it doesn't really make sense to run this sort of an algorithm to find the best path when it's fairly obvious what it's going to be. But in the case of maybe seven, eight, nine, maybe even 20, it becomes a lot more or a lot less trivial what the best path would be. Um, as far as the lessons learned, when we were putting this together, the big ones had to do with version control with GitHub. We found that multiple contributors was working with multiple contributors was not so straightforward, and making sure that we knew what files we would be working on beforehand and how they would integrate was very important. Additionally, we found that there were some issues having to do with our Python package versions, which we had to sort out, but that was another source of trouble. So yeah, overall, this was a moderately challenging project, and I feel like both of us learned a good bit more about ant colony optimization, working in Python, and especially version control. So thank you for your time, and I wish you a good day.
All right, thank you.